Start your day the wholesome way.
Okay, good evening, everyone. Can you hear my voice? Okay, so I'll wait for 2 minutes so that more people can join and then we can start with the session. Okay, so let me start with the session today. So a very warm welcome to all of you for today's session. Today we are going to discuss the topic which is optics, and I'll try to cover every portion of reflection, refraction, everything in this session which I am going to take today. So I'll start with basic property of light. So what happens is uh, if I talk about characteristics of light, it's an electromagnetic wave. So first of all, let's discuss what is light. So light is a form of radiant energy which excites vision. So it's a form of energy, first of all. Then what happens if I talk about source of light? We have natural source of light, which is sun, and we have artificial source of light or man-made source of light. So which are your bulbs, you can say candle, or tube lights. So all these things. Now there are these sources of lights are divided into two specific categories. One is called point source. So if you see, a lot of questions are asked, specifically numericals in your examination, where you are asked that a light beam or a ray of light is coming from point source. What do you mean by point source? So point source is defined like this. So suppose there is a source of light which has been kept over here, and there is an observer who is sitting over here. With respect to observer, if the dimensions or the size of this source of light is negligible, this source of light for this observer would be considered to be point source of light. And what happens if with respect to observer, this source of light is not negligible, or size of source of light is not negligible? Then what will we call it? We will call it extended source of light. So I define two kinds of sources: point source and extended source. So point source was where the size of the object emitting light is negligible with respect to observer. That would be point source. If it is not negligible, if it has some dimensions, it is comparable with respect to observer, then it would be extended source of light. Now let me move to the actual thing which I have written here. So this is basically, give me a moment. This is basically this is electromagnetic wave. So light is called electromagnetic wave, though it does not have any charged particle, it does not represent, or it does not have any magnetic particle. Even in that condition, light is supposed to be electromagnetic wave, because it is in form of wave, where electrons, if you put electron in that source, it will show some kind of oscillation. So let's not get into much deeper details of it. So light is known as electromagnetic wave. What is the next property? So I have seen a lot of question based on characteristics of light. So I have seen a 2-marker question or a 3-marker question based on write two properties of 2 characteristics of light or 3 characteristics of light or 5 characteristics of light. So that's why I have jotted down all the points for your reference so that you can get it at one source. So the first and the most important part of light is that it's an electromagnetic wave. Second is it does not require medium for its propagation. And how do you prove it? So when light travels from sun and it reaches us, it travels through so many mediums, which includes vacuum also, where there is no atmosphere. And it enters our atmosphere with different layers of density. It reaches us, which shows that light does not require any medium for its propagation. Now in vacuum, the density of light is, sorry, the speed of light is 3 into 10 to the power 8 meter per second. Now this fourth point is very important. Speed of light is different in different medium. So always try to understand any particular wave would always have a wavelength and some kind of frequency. So light waves, so if I talk about light, and white light would have your Vibgyor. So VIBGYOR. It is combination of these 7 colors. So if I talk about these 7 colors, all 7 colors have different wavelengths and different frequency. So if I go from V to R, lambda, which is wavelength, increases and frequency will decrease. So what happens in vacuum, the speed of all the different 7 components of light would be same. But as soon as the light enters a different medium, suppose this is medium 1, and this is medium 2. Now a white light goes and penetrates the boundary like this. All 7 colors will observe a change in the wavelength. So what happens? I'm writing 2-3 things which are very important, and you should also write it with me. First thing is that whenever light changes medium, the wavelength of different components of light, the wavelength of different colors of light will change. So wavelength lambda changes, hence speed of light changes. So what happens is speed will change, lambda will change, but one thing which remains constant, and this is very, very important, frequency is constant. So in this particular scenario, what happens is the color of the light, the speed of the light is different in different medium. Why it happens? Because as soon as the light will get into a different medium, the wavelength of the different components of light will change, and hence it will observe a change in speed, though frequency never changes with change in medium. Second, color of the light is determined by the wavelength. So this is one property. Light always travels in straight line. Now I have already explained these 2 points because it was required over here. So I have written here, if change in medium, light does not change frequency, while speed changes, and speed of every color of light is different in different medium except vacuum. So all these points I have already explained to you here. So as soon as you see a question based on characteristics of light in your question paper, you write, first point that you should write is that light is electromagnetic wave. Second point, if you have to write 3 points, I'll tell you this should be the first point, that it's an electromagnetic wave. Second point should be it does not need any medium for propagation. And third point, you can choose any one of them. So if you want to write a simple one, you can write it travels in a straight line, because, and if you have time, if 4.5 points have been asked, you can include all these points. So in this order only you should write these things. Now let me move ahead. Now what happens is, there are few other terminologies which are important. So we need to understand what is beam of light and what is light rays and all these things. So first I'll define optical medium. So any medium through which light passes. Through which light passes. Is only this definition sufficient, that any medium through which light passes? No, there is one more condition, that light should not lose much of its intensity. So any particular optical medium is defined by its capacity to pass the light or let the light waves navigate without much loss in its intensity. So any medium through which light passes without much loss in intensity is known as so if somebody asks you to define optical medium, you can define optical medium by this. Okay, one second guys, there is, okay, now what is type of beam? So type of beam, you can, these are small things. Type of beam is a parallel, convergent, divergent. I'll come to I'll define parallel, convergent and divergent beams for you. Parallel beam means which is parallel to the axis. So let me define it for you. Parallel beam is so if any particular beam is like this, moving like this after emanating from point source, that would be parallel beam. Second one is convergent or divergent beam. So divergent beam, like sun rays, so they diverge in all the direction after they get emanated from the sun. Convergent beam means all the beams converge together from all the direction on one place. So this is what is called convergent beam. Now let's move to the important topic, which is law of reflections. So law of reflections can be defined by, there are 2-3 laws which I have written. So let me make some space for you so that I can. So law of reflection. So what is law of reflection? So try to understand, there are 2-3 things that we can understand here in law of reflection before going to the 2 laws which I have written over here. So first thing that I want to tell you, that light has 2 properties, or light is studied on 2 different bases. One is particle theory of light, and second is wave theory of light. So what is a particle theory? Suppose a cricket ball. So what happens if this is a ball and this is cricket ball, it goes and strikes this particular wall. What happens? The wall reflects its back. The same mechanism can be understood in the case of light particles also. So what happens in this particular case is that suppose this is a plane surface and which has been polished on the other side. So what will happen is that if I draw a normal to this particular surface, and suppose this is the incident ray, and suppose the incident angle is I, so light will get reflected from here. So the first law of reflection says that this incident ray, reflected ray, this is IR incident ray, this is reflected ray, which is RR, and normal to the plane of incidence. So this is the normal. So suppose this is my surface AB, the light strikes at point O and OM is the normal. So IR, RR and OM, these three line segment or ray segments would be in same plane. The second one is very important, which says that angle of incidence is equal to angle of reflection. So whatever angle this incident ray will make with this normal, so what mistake generally student make in examinations, and I have seen it many times, that they take incident angle with respect to this mirror. So this mistake you should not make. Whenever you are taking incident angle, you should take the incident ray and normal to the mirror, not the mirror. This is not I, this is not I, this is I. The angle between the incident ray and the mirror. I have seen many a times people making this mistake. Please be aware of this fact. And similarly, the angle of reflection is also measured from the normal to the reflected ray. So angle between the normal to the incidence and the reflected ray is known as angle of reflection. So please have these things in mind before attempting the question. Now let me move to the other section. So let me define to you the different kind of mirrors. So one thing which was very important in case of angle of reflection is that suppose angle of reflection is, this is the incident ray. What happens when the incident ray is in the same direction of normal to the normal to the mirror? So it means that this angle of incidence is making 0 degree with this normal. So if I is 0 and I is equal to R, then R will also be 0 degrees. In that particular scenario, what happens is that the reflected ray retraces the path. It means that whichever direction it comes from, it reflects itself back to the same direction. So this is called condition of no reflection. I've seen one or two questions where either you are asked condition of no reflection or no refraction. So if condition of no reflection is asked to you in the examination, what you should do is you should make this diagram at least. Without this diagram, your marks would be deducted. And after that, you should write that if incident ray is normal to the mirror, which means that I is equal to 0 degree, that also means that R is equal to 0 degree. In that case, the light would not, or the light would get reflected in the same direction. So this diagram is important, and then one or two line which specifies or which throws a light on what is happening in this particular figure will give you accurate marks while attempting this question. Now let me go to the other parts of it. So what happens, spherical mirror, I am taking two kinds of mirror, which is concave mirror and convex mirror. So always remember one thing, that this concave and convex lens comes from the ability of reflection. What do I mean by this statement is that a mirror, when the part of mirror which is reflecting the light is concave, then it will be called concave mirror. So this is the cave. You can see that this cave portion of the mirror is reflecting the light, and it has been polished on the other side. So polishing is done on the convex side. So this side is called, suppose this left side is called concave side, and the other side is called convex side. So always remember that the size which is reflecting the light, the name is given by that. So if concave side is reflecting the light, it is called concave mirror. If the convex side is reflecting the light, so suppose I mirror the concave side and convex side is reflecting the light like this, so this will be called convex mirror. Now I am taking the example of concave mirror to explain you what happens and what to, I mean, I'll discuss the important terms related to mirror. So suppose I take a concave mirror. So first thing is pole. So concave mirror, any mirror would be cut from some solid glass, and it would be a portion of solid glass. So if I take that solid glass and cut, suppose this is circular in nature, something like this, circular in nature, I have taken only part of that as mirror, and the other part I have just polished it. So the center of this particular periphery, from A to B, whatever periphery is this, the center of this periphery is known as pole. The second thing is center of curvature. So from whichever sphere I am cutting this out, center of that particular sphere would be known as center of curvature of this particular spherical mirror. So suppose this is the center of a sphere from where it has been cut down, this would be known as center of sphere. Now distance between any point on the mirror from the center of curvature is known as radius of curvature. So distance between this pole P, pole is denoted by P, center of curvature is denoted by C. So CP, length CP is equal to radius of curvature. If I take any other point, like I take point here, and what happens is, suppose this point is M, so this line CM will also be radius of curvature, because any point on the periphery of it will have equal distance from the center of curvature, that would be equal to radius of curvature. Now what is principal axis? Line joining center of curvature. So this line which is joining center of curvature to the pole is known as principal axis. Now there are two other important terms, which are focus and focal length. So what is focus? Any light ray which passes parallel to this principal axis passes through a point. Whichever point it passes through, that point is known as focus. So what is focus? Line parallel to principal axis after reflection from the mirror passes through a point. Whichever point on the principal axis the reflected light passes through is known as focus point. And distance between this focus point F and pole, distance between F and P is known as focal length, and focal length is denoted by F. Now, there are other different terminologies. So first one is linear aperture. What is linear aperture? Let me draw this diagram once more so that you understand properly. So there are 3-4 more terminologies which are less common in nature but may be asked in the examination. So linear aperture. What is linear aperture? So suppose this is my spherical mirror, concave mirror I am taking, and whatever between two ends of the periphery, whatever distance this linear distance is, this linear distance AB is known as linear aperture. So what is linear aperture? The linear distance between the two ends of the periphery of the spherical mirror is known as linear aperture. Now, what is angular aperture? So angular aperture would be, try to understand, draw a line which is principal axis. What is principal axis? Any line between the center of curvature and the pole. So the angle subtended by the two ends of the spherical mirror, the angle subtended by the two ends A and B here in this case on the center of the curvature is known as angular aperture. So whatever angle, this theta, so angle ACB here, which is equal to theta I am assuming, is known as angular aperture. Now next one is paraxial axis. So what is, sorry, paraxial rays. So what is paraxial rays? Paraxial rays is any ray which is nearer to principal axis. So what happens? Let me categorize the rays which fall on the spherical mirror. So suppose this is my concave mirror. Rays which are very closer to principal axis are known as paraxial rays. So what about rays which are farther from this principal axis? So rays which are farther from the principal axis are known as marginal rays or peripheral rays. So this is how it is. Now, what do you mean by convergence and divergence of rays? So try to understand. To understand convergence and divergence of rays, we need to understand how convergence and divergence happens. So you see here, I'll explain this, what I'm writing. Concave mirror is also called converging mirror. And convex mirror is also known as diverging mirror. Now, why it is like this? So try to understand. It applies the basic formula of reflection, the second law of reflection, that I is equal to R. So I'll explain this phenomenon here so that you can understand it properly. Suppose this is concave mirror and I'm drawing a line from here. This is my center of curvature. Now you should know that in a circle or in a sphere, any point on the mirror or on the point, any point on the circle or a sphere, if I draw a line from the center, so line joining the center and any point on the circle or a sphere, so let's say here mirror here would be perpendicular to this particular surface. So this line CP is perpendicular to this spherical surface over here. So any ray which is coming and striking this point, suppose this is I, now R would be on the other side of this normal, or reflected light would be on the other side of this normal. So this reflected light goes from here. So what happens? This is your R. So what it is doing, it is bringing everything. So what, let me draw a line from this side also. So this is my normal and this is my reflected light. So see what happens, the light which is coming from here, this is ray 1, this is ray 2, and this is, or let me call it I1 and I2 so that you can understand properly. So two lights, two different rays I1 and I2, and two reflected rays R1 and R2. What happens with R1 and R2? R1 and R2 converge at one point because of the shape of this particular spherical mirror. It's such that it brings all the reflected light together at this focus. So this is why this is called converging mirror. In case of convex mirror, what happens? So this is the center and this is the pole. So I draw a line. So this will be line parallel to. So what happens? Let me extend this. So now this is suppose I. So this is I1. And you see here, this reflected light goes somewhere. So this is I1, this is R1. So this reflected light is going away from the mirror. So what happens is it is diverging in nature. So due to the nature or due to the shape of these two kinds of mirror and the polishing on different side, one type of mirror which is concave converts into converging mirror, and the other type which is convex converts into diverging mirror. So I hope you understand this concept, and if nature of this mirror is asked and how it is converging and diverging, you can draw these kind of diagrams and easily get marks. In your examination. Now let me move to the next slide. So there are different rules for constructing images. So what are those rules? So there are basically 4 rules which apply in both the cases, both in concave mirror and convex mirror. So those rules are, first rule is let me draw a diagram for you. So suppose this is my concave mirror. So I'm doing it for concave mirror. I'll explain it for convex mirror also. First rule is any ray, suppose this is center of curvature, this is pole, this is focus. So first rule says that any ray which is parallel to the principal axis after reflection will pass from the focus. So this is the first rule. A ray of light incident parallel to the principal axis after reflection passes through principal focus. So this is the first point. Second point is that if a ray passes through focus, so suppose a ray passes through focus, after reflection, it becomes parallel to the principal axis. So it is actually a case of reversibility. So if I am making a question paper and I want to ask you that explain me the concept of reversibility in case of concave mirror, you should make these two diagrams and show it to me. You can say that when it is parallel to principal axis, it is passing through focus, and when it is passing through focus, it is parallel to principal axis. So it's actually the same case. If it is coming from this side, it will go this way. If it is coming from the other side, it will go this way. So this is the principle of reversibility in case of concave mirror. Third point, which is very important, is that suppose this is a concave mirror and this is C, this is F, this is P. So any rays which comes through center of curvature will retrace its path. Why it happens? Because see, at this point M, what is the normal? Cm is normal, and incident ray, this incident ray Cm is, I mean, overlapping with incident ray. Suppose I take a different name, I1. So incident ray I1 is overlapping with Cm. It means that I is equal to 0 in this case. If I is 0, then R is also 0. Hence, it retraces its path. It goes back on the same path. So any particular ray passing through center of curvature will retrace its path. Now, fourth one is that if I have any particular, give me a moment. A ray of light coming and striking the pole. So whichever angle it is striking with the pole, because this is this particular principal axis at pole also works as normal to this spherical surface. So this angle between the incident ray I1 and this principal axis CP, this angle would be I1, and it will make the same angle here. So suppose this is R, so this angle I would be equal to R. So what I am saying is that if a ray comes and strikes the principal axis, it goes on the other side on making the same angle with the principal axis. So these are the four laws which are important, or which are called rules for constructing images. So if somebody is asking you in the question paper that write down rules for constructing images formed by spherical mirrors, you can write it in this way. You can make these four diagrams, and that should be sufficient enough for you to get full marks. Now, what happens in case of convex mirror? So that is very important. Why? Because I have not discussed till now real image and imaginary image. So now I'll discuss real image and imaginary image with you with the help of few figures. So now try to understand what happens in case of concave mirror as it is converging in nature, and suppose there is any light passing through, something like this. Suppose there is any light passing through it and getting reflected like this, and there is one light passing through this. Suppose this is focus and passing through this, and this matches here. So what happens here is the image would be formed something like this. So now these both the reflected rays can be captured on a screen here. So what is a real image? A real image means if reflected lights can actually be captured on a screen, that image would be known as, if I put a screen, I'll find out image of the object here. Suppose object is here somewhere and I'm finding the image here. This image can be captured on the screen here. In case of convex lens, what happens? As it is diverging in nature, so what happens is that, so suppose any particular ray go from this side to here, and after reflection goes here, from this side it goes here. After reflection, this goes here. So none of the lights would you will be able to show it on a screen. It is diverging in nature. So this reflected light is going this way, this reflected light is going this way. None of the reflected lights are merging at one point or on a finite plane. So what happens is, if it is not merging on a finite plane or on a point, you cannot capture it on a screen. And if you cannot capture it on a screen, what happens is you don't find a real image. All these will get merged on a point somewhere here. But this point where they are merging, no actual light is coming here. If you put a screen over here, as the light is reflected from this surface only, actual light is not falling back on this screen. So this kind of image is known as virtual image, made by extension of reflected lights. So this is what it is called, vertical image. So always vertical image. In case of real image, we talk about a language that image is formed, and in case of virtual image, we use a particular language which is called image is appeared to be formed. So you should understand the difference between image is formed and image is appeared to be formed. Image is formed is used with real image scenario, and appear to be formed is used with virtual image scenario. So in case of, if I talk about rule of constructing images with, one second, for convex mirror, it's the same thing, but in all the cases I'll be using language that image is appeared to be formed. So here also, if a line parallel to principal axis is there, after reflection it appears to fall or pass through the focus. The second thing is, if any particular line appears to be, or any particular ray appears to be passing through focus, so suppose this is focus, so passing through focus after reflection becomes parallel to the principal axis. Third thing is same, that if any particular light, if it passes through center of curvature, or if it appears, in case of convex lens, if it appears to pass through center of curvature, suppose this is center of curvature, and suppose a light appears to pass through center of curvature, it retraces its path back, and suppose something hits the pole at angle I, reflection would also will happen on angle I. So everything is same, just the language is different. In case of convex lens, we'll use the language of appear to be. In case of concave lens, we will directly write that the image can be formed. Now what is Cartesian sign convention for reflection? I'm telling it for concave mirror, it is true for convex mirror also. So first thing is, any distance measured, any distance measured in direction of path of ray that is supposed to be positive. So suppose there is an object here and a ray travels through this direction. All the distance in this direction will be considered to be positive, and all the distance taken opposite to the direction of path of ray would be supposed to be negative. So this is positive, this is negative. Now second point is, from where do you measure the distance? So we measure all the distances from the pole. So there are 3 points that I talked about. This was pole, this was focus, and this was center of the curvature. From where do you measure the distance? So suppose object is here. Is this the distance that I need to take, or is this is the distance that I need to take? So suppose this is I, sorry, this is O, object. So all the distances are measured from pole. So second point is all distances are measured from pole. As simple as that. The third point is object is always taken on the left hand side of the mirror. So when I place the object, I suppose mirror to be like this. So object will always be considered on the left hand side of the mirror. So this is the third point. Fourth point is, so how many points we have discussed? Positive when it travels through, when the distance is in direction of the rays. Second point is negative when opposite to the direction of the ray. Third point is all the distance from the pole. Distance has to be measured from the pole. Fourth point that I discussed, that object has to be on the left hand side. Fifth point is anything above the principal axis. So above the principal axis, it would be considered to be positive. So you can understand that anything below the principal axis would be considered to be negative. So height above the principal axis is positive, height taken below the principal axis is negative. And all the angles which are measured in anti-clockwise direction. So angle in anti-clockwise direction is considered to be positive. Any angle measured in clockwise direction is supposed to be negative. So these are the important points from the point of view of Cartesian sign convention of reflection. So I'll repeat it for you, that if you measure a distance in the direction of path of the ray, so that would be positive, opposite side would be negative. All distances are measured from the pole. Object is always placed on the left hand side of the mirror. Any height above the principal axis would be positive. Any height below the principal axis would be negative. Angles measured in the anti-clockwise direction is positive, and angle measured in the clockwise direction is negative. Now let's decide a few things about our concave and convex mirrors. So what about focal length and radius of curvature and all those things about concave and convex mirror? So please understand that suppose this is concave mirror and object is placed over here, so light ray will always go in this direction. So this is the direction of flow of light, and this is my center of curvature C, this is my focal point F. Try to understand, if all the distances are measured from pole, so this focal distance would be in opposite direction of travel of light. So concave length, for concave length, this focal length would be negative. For convex length, what it will be? So suppose object is here and light ray is traveling in this direction. And this is the focal point. So this is the distance I cover. So for convex lens, this would be positive. Similarly, radius of curvature would be negative here because I am measuring in opposite direction. Radius of curvature would be positive here in this direction. So this is how you have to understand Cartesian sign convention. Now let me move to another topic, which is position and nature of image. So this particular question is asked in most of the question paper, and there are so many possibilities. So let me discuss it for a few possibilities. So if I talk about concave mirror, what happens is that you should understand that. Let me finish it in 2 minutes quickly. So there are different distances which are considered over here. So let me make a diagram for you. Suppose this is pole, this is center of curvature, and this is focus. So what I'll assume is that suppose any object or any particular point source is at very large distance. So always understand, whenever I use this language in optics, that very large distance, by very large distance what I mean is that the rays coming from that source I am considering it to be parallel to the principal axis. Now from the rule of constructing image, I know that if any ray is coming parallel to the principal axis, all these rays will converge on the focus. So if distance of the image, and always remember, distance of image in optics is denoted by word u. Distance of, sorry, I'm sorry, distance of object is denoted by word u, and distance of image is denoted by letter v. So letter u and letter v. So if u is infinite, which is in this case, v would be at focus. And this, as this is the image is getting formed only at one point, so size of the image would be infinitely small. So this is called diminished in optical terminology. So next one is, suppose I take, if u is equal to f, second case I am taking, I'm not taking all the cases. So if u is equal to f, if an object is kept over here at f, what happens is, so suppose a light rays goes from here, so it will trace its path back and it will pass through center of curvature, and anything which passes through this, again it will trace its path. So all these lines will be parallel to each other. So hence they'll, if u is equal to f, v becomes infinite. So when u was infinite, v was equal to f. When u became f, v became infinite. So these are the cases that you need to understand. So try to find out all these things and mug it up properly, so that you don't miss any this kind of question. One way, one trick to solve this kind of question is that you take your, you draw a line and take any point, and you draw an arc like this, and after drawing the arc, measure this length. This would be your radius of curvature, and exactly half the point would be your focus. I'll prove that radius of curvature is 2 times the focal length in next of the slides. And what happens is that whatever distance that has been given to you, you put your object there, and from there you start drawing a parallel line and a line passing through center of curvature, and wherever it meets. So I always see that a lot of people make mistake in this kind of question. You should never make a mistake. Even if you don't know or you don't remember how to draw this diagram, you just do one thing. You take your compass and you draw this kind of arc, and from midpoint of it from midpoint of it you draw a lines which passes through center of curvature, and half of the point would be focus, and you put your object at the place where it has been given and start drawing a line parallel to principal axis and one passing through center of curvature, and wherever they meet at that particular point your image would be formed. So if you do this particular exercise, it's better to lose 1 marks than to lose 5 marks or 3 marks. So do this exercise at least on your copy, which it is not difficult. It can be found out very easily if you draw a correct diagram. Now let me move to next slide. Okay. So now I'll prove that I'm proving this that f is equal to r by 2 or r is equal to 2f. It means that radius of the curvature is 2 times the focal length. Now how do you prove it? So suppose, let me draw a diagram for you. Suppose there is a light ray coming like this, and this is my center of curvature C. So from this is parallel to principal axis. So suppose this is C, this is F, this is P, and after reflection it will pass from this. So suppose this incident light is AB and reflected light is BT, and suppose this concave mirror I am assuming to be MN. Now what happens is, you look at here, let me draw another, do a construction. So this CB is perpendicular to the surface of MN at point B. Now this is the incident ray I and this is R. Now I is equal to R. Now what would be this angle? So you try to understand angle ABC is equal to angle BCP. Why it is so? Because AB is parallel to CP. So these two would be alternate interior angles. So what happens is both these angles are equal to R. So in triangle BCF, opposite to this side CF is there, this angle CF is there, and opposite to angle B line CF is there, and opposite to angle C line BF is there. Now try to understand, in a very small aperture, this line BF, if this aperture is very small, this BF would be equal to FP. So what I'm trying to say is that if aperture is very small, if this distance is very small aperture means I am assuming BP to be negligible, equal to 0. So this line, if it becomes to 0, this particular line BF will keep on coming down and become FP when BP BP becomes almost equal to 0. So what I'm saying is BF is equal to FP. So I'm writing here BF is equal to FP. Now what I have to do is that I know CP is equal to CF plus FP. Or I can write that so what I need to do is that I have already written that CF is equal to BF and BF is equal to FP. So I am writing CF is equal to FP. So CP is equal to FP plus FP. So let me write here CP is equal to FP plus FP. And what is FP? FP is equal to focal length. You see here, what is this? This is your focal length F. So CP, which is your radius of curvature R, is equal to F plus F. So R comes out to be equal to 2F, or you can write that F is equal to R by 2. So this is how it is. So I hope you understand this complete derivation. Now let me move to proving your mirror formula. So your mirror formula is 1 by V plus 1 by U is equal to 1 by F. Now how do you prove it? So to prove this, concepts of similarity are used. So I will draw a diagram. Please look at it. This can come as 3-4 marks question, or maybe a so what I do in this case is that I take an object. So suppose first let me mark over here. Suppose this is center of curvature C. This is focal point F, and this is P. So let me have an object. I name the object as AP. This is my concave lens. Now, as I told, what I'll do, I'll draw a line parallel to principal axis, and this will go from the focus here. And I'll draw a, give me a moment. I'll draw a line from the center of the curvature, and I know that if a line passes through center of the curvature, it retraces its path. So where does this two reflected rays meet? They meet at point, suppose this I call as A dash, and this would be the image formed A dash, B dash. So now it's all, everything now is the application of concept of similarity. So I'm just removing this so that I can write it. So I'm taking triangle ABC. I know that triangle ABC is similar to triangle A dash B dash C. Why? Because this is 90 degrees, so this is 90 degree, and these two are opposite angles. So if two angles are same, third angle has to be same. So the thing would be that ratio of corresponding sides would be equal. So A dash by A dash B dash divided by AB would be equal to B dash C divided by AC. No, once again, I have made the diagram. I need to change the diagram here because I've taken B dash on the principal axis. So B dash by BC. So this is the first equation which I am making. Now second equation, I will take it from this triangle, and as I already told you, this length FP, let me draw a perpendicular from here. So suppose this length, I'm calling it as, suppose this point is D and this point is N. So I am telling that Fn is equal to FP. Why? Because if aperture is very, very small, this length NP would be negligible to 0. Hence, I am assuming that Fn is equal to Fp. Now, try to understand. In triangle, I am taking the triangle on the other side. I am taking triangle A dash, B dash, F, and triangle D, N, F. So I am taking this triangle, and this triangle. Again, these two are opposite angles, so that would be equal, and this two would be 90 degrees. So they are similar in nature. So you try to understand, it would be A dash by B dash divided by B dash F, that would be equal to dn divided by Fn. Now you try to understand, if these two lines are parallel, AD, I'm writing here, if AD is parallel to BP, then you automatically understand that AB would be equal to dn, because this becomes the height of the object. And I already know that Fn is equal to Fp. So now what I'm doing is that I'm just changing it a little bit. A dash B dash divided by dn is equal to B dash F divided by Fn. And I'll replace dn with, what I'll do is I'll write A dash B dash, I'll replace dn with AB, and B dash F divided by Fn I'll replace with Fp. So now this is my second equation. Now from equation 1 and 2, A dash B dash by AB is equal to B dash C divided by BC, and B dash F divided by Fp. So I can write here that B dash C divided by BC is equal to B dash F divided by Fp. I can easily write that from these two equations. Now, what is B dash F? B dash F is this PB dash minus PF divided by this complete length. This length from here to here would be this complete length from pole to here minus this length divided by BC. I can write it as PB minus PC. That is equal to, no, 1 second. I've written B dash F, so I will have to write here FP. FP will remain FP. And B dash C, I'll write that. So B dash C would be PC minus B dash P divided by BC. I can write as PB minus PC. So what I get over here is, I get over here now, what is P? So you look at here, PB dash. What is PB dash? PB dash is where image is formed, and it is in the opposite direction of the ray. So I'm writing here minus V. This PF would be how much? PF is focal length. Again, this is negative, minus F divided by FP. FP is again minus F, and that is equal to PC. So how much is PC? PC is equal to 2F, because PC is radius of curvature. So I'm writing it 2F, but it will come with a negative sign, minus 2F. B dash P is again minus V divided by PB. PB is equal to minus U minus PC. Minus PC will again be minus 2F. So let me remove this for you. Let me remove these things for you. If you solve this equation, so this comes out to be minus v plus f divided by minus f is equal to v minus 2f divided by 2f minus u, which becomes f minus v divided by f is equal to v minus 2f divided by 2f minus u. If you do the cross multiplication and everything, you will find that it will come out to be 1 by v plus 1 by u, that would be equal to 1 by f. So this is the formula of mirror. Please remember it. Whenever you are putting the values, put the values with the sign convention. Generally people make mistake. I'll make videos on for the numericals also, but as I'm doing the mirror formula here, I'm reminding you once again that whenever you are doing these kind of questions, never forget the sign convention. The most important thing in the case of mirror formula is sign convention. If you put the sign convention, if you follow the sign convention properly, you will never make a mistake. Now in this case only, you can easily find out the formula of magnification. So formula of magnification is I have written here size of the image hi by ho is equal to minus v by u. So this is your formula of magnification. Anyone you can use. Magnification is also this size of image divided by size of object. For mirror it is minus v by u. So you can prove it through the similarity diagram which I just made uh, on the slides. Now let me move to another important topic. So let me go to refraction. So I hope you understood the concepts of reflection pretty well. Now refraction. What is refraction? So till now we were discussing about the light rays which were coming to the medium, coming back to the same medium after getting thrown away from the optical medium. So there was a mirror kept over there and it was polished from the other side. So what happened is that whenever any particular light ray struck with that mirror, it was thrown back again to the same medium. It is not always the same. What happens if I don't polish the other side? So in that particular case, or normally also in different situations, light passes through different medium, and when light passes through different medium, I have already explained that there is a change in the wavelength of the light when it goes from one medium to another medium. Due to change in the wavelength, the speed of the light also changes. So optical medium I have already explained you. An optical medium is any medium through which the light passes through without its intensity getting affected much. Now optical medium can be classified into two categories. The first category is rarer optical medium. The second category is denser optical medium. So what is a rarer optical medium? So as I have already told you that the speed of the light changes in different medium. So if light goes from one medium to another medium such that the speed of the light increases. So if light starts traveling faster than the other media, it is called optically rarer medium. The second case is denser medium. In this particular case, the speed of the light reduces from the previous medium from which it is coming. So if the light increases, if the speed increases, it is a rarer medium. If it speed decreases, it becomes the denser medium. So let me draw a diagram for you and let me explain over here. Suppose this is medium 1 and this is medium 2. A light is coming like this. Now this is incidence angle, and suppose it is getting refracted like this. Suppose this is angle of refraction. Now if this particular light wave, suppose speed is v, and suppose medium 1 I am assuming to be air, and in air the speed of light is denoted by c. So if v is greater than c, this is rarer medium, and if v is lesser than c, that is denser medium. Now always remember that optical density is different from normal density that we discuss. For an example, let's take kerosene. So when you put kerosene in water, kerosene starts floating on the water. What does it show? It shows that the density of the kerosene is lesser than, the normal density of the kerosene is lesser than that of water. But in case of light, speed of the light reduces more in kerosene than in water, which shows that kerosene is optically more denser than water. So always remember that the density which I am talking about here is not normal density. I define it as optical density, and optical density is different from normal density. Anything, I mean, you cannot compare optical density with normal density. I gave you an example of kerosene in for that matter. Now let's discuss the direction of bending, or how the bending happens, and what is the phenomenon of bending. So please understand here. Suppose this is the medium which is separating, and this is another medium I'm taking. I'm making two diagrams. So suppose this is medium 1 and this is medium 2, and there is an incident ray over here. So if medium 2 is rarer than medium 1, so the light ray deflects away from the normal. So in this case, angle of refraction would be more than angle of incidence. Here, this is M1 and this is M2. If M2 is denser than M1, so light rays deflects towards the normal. Here light ray deflects away from the normal. Here light ray deflects towards the normal. So R would be lesser than I. So why this phenomenon happens? Because I have told you that frequency remains the constant when the medium changes, and only wavelength changes. So so there is a band party theorem over here. So suppose this is the direction in which the band party is moving. So what happens is, suppose this is normal road and I put sand over here. So sand is more denser, or in sand the speed of the human being coming from a road, normal road, will reduce. So whichever person comes over here, will, and suppose there is a person over here or over here, will take a path which provides them a path which takes the least time crossing this sandy path. So try to understand, light always follows, in any medium, light always follows that path which provides its least time to cross that particular medium. It is not the path which is shortest. It is the path which takes the shortest time. So light always takes that path which takes shortest time for it to pass that particular medium. And that is why this particular human being which is coming like this will start moving towards here, so that he follows this path and moves away from this sandy path as soon as possible. So this is how the bending of the light happens in this particular direction. So always remember that whenever a light goes from denser medium to rarer medium, the bending will happen away from the normal. Whenever the light goes from rarer to denser medium, the bending will happen towards the normal. Now let me go to laws of refraction. So I have already explained you the bending of light. So now let's understand. So suppose this is incident ray I, and this is my medium M1, and this is M2. Before I explain you law of refraction, there is one thing that you need to understand. There is something called refractive index of a medium. Now refractive index of a medium is defined by a ratio. That ratio is speed of light in vacuum or in air divided by speed of light in that medium. So try to understand, speed of light in air, I told this is c, and suppose the speed of light in that medium is Vm. Now try to understand, if it is a denser medium, so Vm would be less than c. If the medium is denser than air, it means that it will slow down the speed of light. Hence Vm would be less than c. If Vm is less than c, then this ratio c by Vm would be greater than 1. So for a denser medium, denser as compared to air, refractive index would be more than 1. If there is a medium where it is rarer than air, in that particular scenario, Vm would be greater than c and refractive index would be less than 1. So that is how you define the refractive index. Now let me go to this particular place. Suppose refractive index is mu1 here and mu2 here. So the first law tells me that this incident ray, refracted ray, and this normal to the point of incidence will be all in same plane. So this is similar to reflection. The second one is known as Snell's law, and it is very important. So I never explain Snell's law as mu1 sine theta 1 and all these things. Always remember refractive index of the medium. So I'm writing mu m multiplied by sine value of the angle in the same medium. So sine theta m will always remain constant. So what happens is, what is the refractive index here? Mu1. And what is the sine value of the angle is this in this medium? I. So mu1 sine I. That if it is equal, what is mu2 here and what is sine value of angle r here? So mu1 sine I is equal to mu2 sine r, because both of them will remain constant. So I am equating the constant here. So mu1 sine I is equal to mu2 sine r. So this is your Snell's law. Mu1 sine I is equal to mu2 sine r. Now let's discuss Snell's law in a bit of details here. So what I'll do over here is, let me just make a little bit of space. So there was a, this was I, this was R, this was mu1, this was mu2. So mu1 sine I is equal to mu2 sine R. So try to understand, sine I by sine R is equal to mu2 by mu1. So if mu2 is greater than mu1, it means that, if, try to understand, if mu2 is greater than mu1, so it means that this is denser medium, because mu2 is greater and mu1 is rarer medium. So what happens is, this becomes greater than 1. So it means that sine I is greater than sine R. So I is greater than R. It means that the light ray is bending to, if R is less than I, it means that this displacement from normal of this refracted ray is lesser than this displacement of incident ray. So it means that I is greater than R, or if R is lesser, it means that it is moving towards the normal. So that's how we prove that if it is going to the denser medium, so R would be lesser than I, it means that it is going towards the normal. In opposite case, it will deflect away from the normal. Now let me go to condition of no refraction. Condition of no refraction is same as condition of no reflection. So what happens is, any light ray which falls or overlaps the normal to this refracting surface, it would be I equal to 0. So mu1 sine I is equal to mu2 sine R. So as mu1 and mu2 are not 0, mu1 sine 0 is equal to mu2 sine R. Now sine 0 is 0, so 0 divided by mu2 is sine R. R comes out to be 0. R comes out to be 0, it means that the light ray keeps on traveling in the same direction. And this is the condition of no refraction. So if somebody asks you condition of no refraction, this diagram should be there along with this particular calculation, and write a few lines about that. If it falls or overlaps the normal, so there would be no refraction, because I is equal to 0 and hence R becomes 0. You get full marks for that. Now let me move to principle of reversibility. So let me move to another slide. So what is principle of reversibility? Principle of reversibility is like this. So suppose this is a medium, and from here the incident ray is coming, and this is I, and suppose this is R. So principle of reversibility means, by explaining it, if it is coming from this side, suppose medium 1 and medium 2, if incident ray is in medium 1 is this, and refracted ray in, suppose, let me put it A, B, C. So incident ray I1 is equal to AB, and refracted ray R1 is equal to BC. So principle of reversibility says that if incident ray becomes BC, then refracted ray will become AB. So if light goes from this direction, it will come out in this direction. So this is the principle of reversibility. Now how do you prove it? So you can take mu1 sine I is equal to mu2 sine r, and you can assume this to be I, this will come out to be r. So you can assume this to be I. Now suppose r is equal to I, so this I will come out to be equal this I will come out to be equal to r. So mu1 sine I is equal to mu2 sine r, and if I make mu2 sine I, so this I'll have to make it from other side, or sine I1. So from other side this I will convert to r. So this is how you prove this. Now let me go to refractive index of two mediums with respect to each other. So how do you solve it? Refractive index of two mediums with respect to each other. So let me make two mediums first of all. So suppose this is air, and on the other side this is also air, and this I am assuming to be water, and this I am assuming to be glass. Now there is a incident ray which falls here. So let me draw a line perpendicular to this. So suppose this I am assuming to be r. So this falls here, and due to alternate angle theorem this will also be r. And if this is r, so suppose this is theta. If this is theta, this is also theta, and this is, or suppose I am assuming it to be theta 1, this is theta 2. So let me write Snell's law for you. So suppose this is mu a, this is mu w, this is mu g, and this is mu a again. So let me write it for you. Mu a sine I is equal to mu w sine r. Now for this surface, this is, suppose this is surface number 1, this is surface number 2, and this is surface number 3. So for surface 1 this is the case. For surface 2 it will be mu w sine r is equal to mu g sine theta 1. And for third case it will be mu g sine theta 1 is equal to mu a sine theta 2. Now try to understand. First of all, you if you equate these three equations, what do you get? So what I get over here is that mu a sine I is equal to mu a sine theta 2. It means that I would be equal to theta 2. Now if you understand by this method also that mu w, or let's take mu a divided by mu w is equal to, or let me take water first here. So mu w divided by mu a is equal to sine I by sine r. And the second equation is mu g divided by mu w is equal to sine r divided by sine theta 1. So there are, and the third equation I'll write here, mu a divided by mu g is equal to sine theta 1 divided by sine theta 2. So I have these three equations. If you multiply all of them, so what happens is, you see here, let me erase it for you. So I multiply all of them, mu w by mu a multiplied by mu g by mu w multiplied by mu a by mu g, and that is sine I by sine r multiplied by sine r divided by sine theta 1 multiplied by sine theta 1 divided by sine theta 2. So what does it give me? It gives me that this sine r gone, sine theta 1 sine theta, and I prove that I is equal to sine theta 2. So this and this gone. So mu w by mu a, mu g by mu w, and mu a by mu g is equal to 1. Or I can say that this I can write as a mu w, this I can write as w mu g, this I can write as g mu a is equal to 1. So I know that w mu g is equal to 1 by a mu w multiplied by g mu a. So it comes out to be w mu g, and whatever I am writing on this right hand side, that goes in the numerator, whatever I am writing on the left hand side, that goes in the denominator. So mu gw is mu g by mu w, as simple as that. Or refractive index of the glass with respect to refractive with respect to water. So here I can write that this will come out to be mu g by mu w will come out to be mu g, because a will get cancelled out. Or let me explain this for you once again. This I will write as, let me make a space here. This I'll write as w mu g is equal to 1 by a mu w multiplied by g mu a. So write it down. This comes out to be 1 by mu w by mu a into mu a by mu g. So this and this gone, this mu g goes in the numerator. So this becomes mu g by mu w. So refractive index of glass with respect to water is refractive index of glass with respect to air. If you don't cancel it out, this will become mu g by mu a, so refractive index of glass with respect to air, and this is anyway mu w by mu a, so refractive index of water with respect to air. So this is how you have to prove that, how to find. So you take an example of glass and water as I took in this example, and you prove that refractive index of glass with respect to water is refractive index of glass with respect to air divided by refractive index of water with respect to air. So that's how you prove this thing. Now let me move to another topic, which is refraction through rectangular slab. So, and measurement of lateral displacement. So how to do it? We'll have to make a rectangular slab. So let's make rectangular slab, and then let me make a rectangular slab for you. So suppose this is the incident ray and this is the refracted ray. This is the normal. This goes away. So this is my medium 1. This is my medium 2. And I am assuming medium 1 to be air. I am assuming this to be glass. So this is I, this is R, this is R. And if this is R by principle of reversibility, this will be I. Now, how do you measure this? So what happens is this is how refraction happens through a slab. Now what is lateral displacement? So this is the actual direction of the incident ray and this is the direction of the reflected ray. So I know that from, see what happens with this normal here, this incident ray was making angle I know that with principle of reversibility, because this is R and this is R, this has to be I. So what happens is that here also with the normal, the final refracted ray makes the direction or makes the angle I. It means that the angle or both these rays, the refracted ray and the incident ray, are parallel to each other. If they are parallel to each other but they are not coinciding with each other, it means that there is some kind of lateral displacement which is there. So to find out lateral displacement, I need to find out perpendicular distance between these two parallel lines, incident ray which has been extended in this direction and final reflected ray. So how to do that? So I know that, try to understand. So for that, suppose this is T. So I am assuming that T is equal to width of slab. Now if T is width of slab, so I will measure this lateral displacement with help of slab. So what I need to do is that I need to find out this particular length. How will I find this particular length? So this is T. So try to understand. Let me mark it A, B, C, X. So I have to find out Cx. Cx is my lateral displacement, LD. So for that, I am finding out AC. So I am taking triangle, which is a right angle triangle ABC. So in right angle triangle ABC, cos R is equal to AB divided by AC. So AC is equal to AB divided by cos R. And what is AB? AB is equal to T. So I am writing it T divided by cos R. Now, in triangle AXC, this complete angle is I, because between normal and the incident angle, the angle is I. So this angle would be actually I minus R. So in triangle AXC, angle CAX is equal to I minus R. So I will write that sine I minus R is equal to CX divided by AC. So CX comes out to be equal to AC sine I minus R. And AC is equal to T by cos R multiplied by sine I minus R. So if lateral displacement you have to calculate, you can use this formula, which is, again I am writing T divided by cos R multiplied by sine I minus R, where T is depth or width of the slab, R is the refracted angle, I is the incident angle. So this is how you can calculate the lateral displacement. This, in your book or most of the book, this cos R is written as secant R. So you can also write T sine minus R cos R as secant R. This is also true for you. So this is how you can find out the thickness of your lateral displacement in terms of thickness of the glass slab. Now factors on which the lateral displacement depends is thickness T, because if T changes, lateral displacement will change, and obviously I and R, because on I and R value this particular thing will depend on. Now let me move to another slide. So what happens is, actually I'm trying to find out that generally you see a phenomenon that if a bucket is full of water and you throw a coin inside it, the coin will not look at the depth it is originally at. The depth at which it will appear to be would be less than its actual depth. Why does this phenomenon happens? So that is what I'm going to discuss in this particular slide. So I have defined it by naming it real and apparent depth, because the depth is the depth at which it is appearing is not equal to actual depth. I call it apparent depth. And how much is the distance between the apparent depth and real depth, that is known as normal shift. So how do we do it? What happens is, try to understand the phenomenon here. The phenomenon is something like this. So suppose there is a light ray here and my eye is here. I'm looking from this particular point. So what happens? There would be a parallel line which is going, and there would be no refraction. There would be one ray which will be going from here, and suppose this is water and this is air. So light is moving from denser to rarer medium, so it will move away from the normal. So this is I and this is your R. And what happens? The object will appear to the person standing here at a point from where refracted ray appears to come from. So let's increase the length of this refracted ray. So as a refracted ray is coming from here or appears to be coming from here, this particular object O will appear to be at this point O dash. This O dash, suppose this point is X, so this O dash X is known as apparent depth, and OX is equal to real depth. So how do you calculate it? So try to understand. Now if this is I, this particular thing is I, and if this is R, so with this, if with this normal, this line is making R, this is parallel to the normal, this angle will also be R. So I am assuming this to be R. So what happens is, so suppose let me put this point as M. So sine R is equal to, in triangle, suppose this is O dash, in triangle MX O dash, sine R is equal to this mx divided by this mo dash, and in triangle mxo, sine I is equal to mx divided by mo. Now try to understand. If this length is very small, if this length is very small, if I consider mx to be very small, in that case mo dash would be equal to xo dash, and om would be equal to ox. So what I can do over here is that sine r is equal to mx, divided by mo dash can be written as xo dash, and sine I can be written as mx divided by ox. So what happens is sine r by sine or sine I is equal to sine r by sine I will be equal to ox divided by xo dash, which is ox is actual height divided by apparent height. So I'm real and apparent I'm writing. Now the sine r by sine I is mu of water with respect to air is equal to hr by ha. Now let me make some space for you. If I write it in other term, HA by HR, apparent depth divided by real depth, would be equal to 1 by A mu W. So this is what the formula that we generally use, that apparent depth divided by real depth. Sorry, this would be opposite here. So apparent depth divided by real depth would be equal to, so what I have used water here, so would be equal to mu of water with respect to air. So this sine r by sine I would be equal to mu of air divided by mu of water. I can prove it. I can write it that mu a here it will be mu a sine I, that is equal to, by Snell's law, mu r sine mu w sine r. So sine r by sine I is equal to mu a divided by mu w. So which becomes so if I write and sine r by sine I is hr by ha. So if I write ha by hr, this becomes opposite. So this becomes mu w by mu a. So this is how you have to prove that apparent depth is equal, apparent depth divided by real depth is equal to uh, refractive index of water or glass, whatever you are taking, with respect to air. So this is what the formula is. So now what is the vertical shift? Try to understand. So apparent depth divided by real depth is equal to mu water. I am only writing. Now let me find out the vertical shift for you. So vertical shift would be, just look at here, the vertical shift would be, if I draw this once again for you. So this is your apparent and this is your HR. So vertical shift would be HR minus HA. So this is, suppose this depth I am assuming to be T. So real height or real depth HR is equal to T. So I am assuming HA by HR, which is T, is equal to mu. So HA is equal to mu WA or mu GA. So HA is T into mu AW. Now you can subtract it and you can find out the formula. So if you subtract it, it will come out to be, suppose this vertical shift I'm taking it to be x will come out to be T 1 minus 1 by A mu W. This is the formula. So I'll remove everything and write down the two formulas that we have just proved. We have proved that real depth divided by actual depth, sorry, apparent depth divided by real depth is equal to mu w divided by mu a, or mu wa, and vertical shift x is equal to t 1 minus 1 by mu a w. It is as simple as that. Now let me move to lenses. It's already 2 hours. So let me move to lenses. I'll prove the lenses formula, and then and magnification, and then I'll finish the syllabus for you. So what is the lens formula? Let me go to the another slide. So let me go to the lenses. So I will discuss two kind of lenses for you. That would be your convex lens and concave lens. So I have already discussed terminologies and Cartesian sign formula in case of mirror. Whatever is would be difference. Principal focus optical center is same from wherever it has been cut. So this is called as your optical center. This draw a line from here, and this midpoint is known as optical center. For this concave lens, draw a line. This is your optical center. Now if a line if a line parallel to this is principal axis, and somewhere here would be your, because a line parallel to principal axis will go from focus, so this particular thing becomes your focal length. Here it will appear to be going from focus. So again, virtual image and real image situation, which we already discussed in case of mirrors. So Cartesian sign formula, important terminologies would be same as it was in mirror. If it is different somewhere, I will discuss that for you. Now let me go to another slide. So let me prove lenses formula for you. So for lens formula, what I'm doing is I'm drawing a convex lens for you. Or let me remove this, and then let me draw a convex lens. So suppose this is my convex lens, double convex lens I'm using, and this is my principal axis. I put an object over here, and a line parallel to principal axis is coming over here. Now line parallel to principal axis will go somewhere from the focus, and line which passes from center of the curvature will keep on going through its own path. So this is where I find out, suppose this is AB, this is N, and this is A dash B dash. Now this doesn't look like, but this is a straight line which I'm trying to follow, and this is center of curvature O. Now I take triangle ABO and triangle A dash B dash O. So here AB by A dash B dash would be equal to BO divided by B dash O. And in triangle let's take this triangle. So I'm taking triangle, one second, I'm taking triangle, second triangle that I'm taking is A dash B dash and suppose there is F here, and I am tracking ABF. Suppose this is F here, A dash B dash F and NOF. So in this particular triangle, A dash by B dash divided by ON is equal to B dash F divided by OF. Now you should know that ON is equal to AB. So what I can do over here is that this is B dash. So A dash B dash ON is replaced by AB, and that is equal to B dash F divided by OF. So this is my equation number 1. This is my equation number 2. With equation 1 and 2, I can write that BO divided by B dash O. So no, this is opposite. So I will have to write it down opposite, because here I have taken AB divided by AB dash, and here I have taken AB dash divided by AB. So I'm just taking reciprocal of it. So B dash O divided by BO is equal to B dash F divided by OF. So B dash O divided by BO is equal to B dash F is actually BO minus OF divided by OF. So B dash O is nothing but position of image, and it is in positive direction. BO is minus U because I am taking it opposite to the direction of the ray. BO again is minus, sorry, this is B dash O. So this is V. OF is minus F divided by OF is F. So V minus U, V minus F divided by F. If you will solve it, you will find that you get 1 by V minus 1 by U is equal to 1 by F. So this is how you find the lens formula. So actually finding out lens formula is pretty easy. First you take these two triangles, and then you take these two. First I'm taking 1 and 2, then I'm taking 3 and 4. So 4 triangles which are in conjunction. I'm proving similarity. So when you are solving it, please write that these are similar triangles, and by writing similar triangle, use this sign so that similarity is proved. So I'm not written here, I'm ending myself. I'm showing that these two are similar triangles, and when you write here, you write a line that for in a similar triangle ratio of corresponding sides are equal. So this is how it has to be. Now let me move to magnification. So magnification, and there was one doubt in case of magnification which I read from somewhere, that whether in magnification, so magnification is height of image. So let me remove this and let me write it in terms of height of image divided by height of object is equal to V by U. Now everything in this particular formula has to be written with sign convention. Nothing here comes without sign convention. So if you find that HI is below principal axis, I will write it minus HI and not HI. If HO is positive, I'll write HO. If V comes out to be negative, I'll write minus V. U is negative, I'll write minus U. So nothing is without sign convention. You cannot write anything without sign convention. It always comes with sign convention. Now what is power of lens? So power of lens is 1 by F. F is the focal length of the lens, and F is always in meters. Generally, F, wherever you have to find power of the lens, F is not given in meter. It has been it is always given like 25 centimeter, 20 centimeter, and in hurry we just write it 1 by 25 centimeter as power of lens, which is absolutely wrong. So when you solve these kind of things in examination, don't do this. You should just write 100 by 25, because if you are converting it into centimeter, so the other formula is 100 by F into centimeters. or 1 by f into meters. So that's how you solve these kind of trickier things. They are not difficult, but they are made trickier by changing the unit over here. Now what happens if different lenses are kept over here? So power would be added. So if 5 lenses are there and powers are P1 to P5, power of all the lenses combined would be P1 plus P2 plus P3 plus P4 plus P5. So this is what the formula is. Now in case of, try to understand guys, in case of convex lens, the focal length is positive, so P divided by 1 by F, this is positive, it is in terms of meter, so P would be positive. Now what is the unit of power? This is diopter. So unit of power is all is known as diopter, and it is denoted by word D. So for convex lens, power is positive. For concave lens, as F is negative, so what happens is P divided by 1 by F, but as this F is negative, so power comes out to be negative. So and with if negative power you see somewhere, you should understand that this is for concave lens, and if positive power you see somewhere, you should find that this is convex lens. So I'll discuss all these things, negative power and positive power, when I am discussing optical instrument in a different class altogether. I've kept a different session for optical instruments. So optical instruments, I'll explain why power positive, negative, where it is used, and all these things. So now let's go to next slide. I have already derived magnification and lenses formula for you. So now let's go to total internal reflection, and this is the this is one of the last topics. Now what is total internal reflection? So first criteria for total internal reflection is that light should, it is first of all a refraction phenomenon. And the criteria is light should go from denser to rarer medium. So let me draw a line here. This is a denser medium, and this is angle of incident I. So light goes away from the normal. Now there would be a value of I for which R becomes 90 degree, and that value of I will be known as critical angle. So what is a critical angle? IC is that value of I for which R becomes 90 degree, and the total internal reflection start coming into picture. So what happens is that if I is greater than IC, then the light rays start coming back to the same medium, and that is total internal reflection. So if you have to define total internal reflection, it has to be demonstrated like this. So I will apply Snell's law for this. So suppose this is mu1 and this is mu2. So mu1 sine I is equal to mu2 sine R. So mu1 sine IC, and at value of IC, R becomes 90 degree. So this becomes sine 90. So mu1 sine IC is equal to mu2, or you can write that mu1 by mu2 is 1 by sine IC. So it means that what is mu1 by mu2? So refractive index of this medium with respect to another medium. So I am writing it by mu. So mu is equal to 1 by sine IC. This is, and what is sine IC? Critical angle. So refractive index is equal to critical angle. So there are different phenomenons, or there are different application of refractive, total internal reflection. One is optical fiber. People or examiner ask why total internal reflection and not reflection. So because total internal reflection is a phenomenon of refraction. So what happens? There are two conditions, or there are two things which are very important in case of total internal reflection, which makes it better than the actual reflection. First is, in case of normal reflection, a lot of light is absorbed by the surface from where it is getting reflected. So intensity of the light gets affected. In case of total internal reflection, intensity of the light remains same because the total light is internally reflected. There is no absorption over there, or minimal absorption over there. The second thing is that in case of a normal surface where it is getting reflected, if there is some kind of dust or some kind of impurity, due to that the reflection phenomenon doesn't happen properly, and due to that also intensity of the light gets affected. The reflection is not proper. In case of total internal reflection, as the medium is same and the light doesn't go out, the problem of dust, mist, fog, any other minute particle can be neglected, and due to this the reflection happens very properly. That is why total internal reflection is preferred in examples like optical fiber and not the normal reflection. So if you write these 2-3 points, you should get proper marks. So with this I come to the end of this particular topic, optics. Now optical instruments are left out, that would be covered in next session. And if you have any doubt, you can post it on our website. You can post it, you can message it to our numbers, Centum Academy number, and you will get a specific, or if you have any doubt, you send it to our number. We will make videos for that, and we will send you solution of all those problems or doubts that are there with you. So don't hesitate in sending your doubts to us. So thank you so much for attending this session, and I hope you enjoyed the session. It was useful for you. Thank you so much.